Kama hii ni species gani?
The next sentence explain the
Sasa ndio shida. Wewe unataka mtu aanze kugeze aende mbele. Somebody has to get the idea and then now anapata more details. So tunasema tu kwamba schematic diagram representing the interaction between raw myosin and ama A, B, ama the species A, B and C. And ukitaka kuongeza hiyo active ama inactive forms. Ama schematic diagram representing the interaction between three molecules or the active and inactive forms of A, B and C, something kama hiyo, alafu inaisha. So kuliko anze kuweza tena mtu aanze kufikiria ndio aanze mbele atafute jibu mbele. Sababu anafanya mbele kutafuta further information, si kutafuta jibu ya vitu amesoma nyuma. Yeah. Haya, vitu kama hizi, ona kama hii. There should be no space between the word na comma. Unajua kama huko nyuma sijaangalia hata. Haya, ona kama hii. Hii umeacha tu imebaki na ingeenda tu hivi. Ona hii ingeenda tu hivyo. Unashangaa una submit hivyo. In fact kuna mtu there's something tulikuwa kwa workshop sama. Mtu akamwambia kwamba some of these papers ukiona vitu kama hizi. And then paper iko na mistakes. Editor ana reject immediately tu, ana reject. Juu wanajua kama mtu hujapitia. Kuna mtu anasema kwamba sometimes people wanapata tu mistakes kama hizi. Ameweka comment kwamba change here, change this. So unaona kama that's comments zinaenda zinapita mbele. Alafu kupata kama hii yote tu. And that's kama zingine now you see nilichukua system ya noted, I'm writing them in capital letters so that zinakuwa tu conspicuous. Hata huko just huko nyuma hata sijaenda hata but I'm still skeptical about hii column 3. Sijui juu kuna kitu mention, sijui kama nilikwambia, sijui kama uliangalia. I'm sure this parameter the set 1 will generate set 3 because whatever is in set 1 is capable of generating ease of touring regions in some cases. Do you are varying beta? So when you mention these vitu mbili, sometimes I get siko sure why. Then you fix, alafu unasema kwamba kama unasema kama ni variable, maybe sometimes it's just better you don't put n numbers ama nini. Juu hapo napata kwamba alpha also varying to some extent. Juu ulikuwa unachora hiyo two parameter bifurcation diagrams zenye alpha pia na change, so sielewi this by my impression kwamba hizo whatever is happening here inatoa huko. Kama kuna kitu kama sijui nikwambia uchange. Kuna comment nilikuwa nimeweka hiyo, unajua saa nyingine huwa unavuta sijui kama ni gani, but kuna comment nilikuwa nimeweka nikakwambia uangalie. There was somebody ulikuwa umesema kwamba hizi haziwezi occur, nikakwambia kwamba whatever you are referring to ni hizi mbili peke yake, hizi columns mbili ndio za temporal. Hii inaingia mambo ya spatial, and this to some extent is just an extension of hii part ya huko, hii column 1, and it might also be an extension of part 2 kama unataka kuona what is the effect of diffusion kwa bistability. So ona ndio nikwambia kwamba when you want to submit this, so the task itakuwa yako, and kama itakuwa yako, you just need to be very attentive kuangalia vitu zingine hizi ndogo ndogo zenye zinakaa obvious, hizo unatoa, and then mostly some of these things zenye zinafanya you lose the meaning of what you are reading. afadhali ikuwe mistake, but kama unajua kama ina lose meaning, then inaanza ku confuse mtu. Kama kuna pale
This one, now the explanation for this why beta not other parameters.
just justify why you used beta. That's in short what you need. Just justify why did you pick beta as bifurcation parameter.
The other parameters were not bringing any changes in the transition from the
No, there
base
is a
plan.
kwa justification ukitumia hizo juu. If you pick an appropriate beta, then the other should also give you transition. So huwezi tumia hiyo. Where is the beta parameter in your equation? Hmm?
Well,
Beta ni inhibition ya
myosin.
inhibition strength. Alpha iko wapi? Alpha ni activation, positive activity. Look for how you can justify this. Maybe something you're just using mathematical, maybe you are just varying parameters to see what happens and then you sijui utajustify aje. Or you try to connect it to biology. And then unaona kama hizi ulianza hapa, you combined null lines zote za bistability na oscillatory. Ukakuja hapa, you combined diagrams za numerical, you have bistability, you have oscillatory in the same figure. But ukija hapa, then you separate. Why don't you just make this to be one figure with the top panel and the bottom panel so that you have uniformity? Juu zile zingine usha combine mbili mbili zote ziko within the same space, instead of having vile uko na figures mingi, reduce the number of figures you have, figure count. So put this as same panel, just ongeza hapa ikue A B C then D E F, hiyo top na bottom panel, alafu ndio explain pamoja hapo, so inaweza kuwa hiyo that consistency. Zingine hapa hata sijasoma hiyo, nimeangalianga tu. Turing spaces corresponding to system 9 with pairwise parameter combinations with variations parameters. Eh? Hii nimeweka green. Ona, check hizi vitu zote hapa, uangalia hakuna spaces kwa kati hizi vitu ukiandika hapa. And the same thing nimekwambia hapa, spaces in math mode. Then this statement you sometimes had ulikuwa na table mahali ilikuwa ina summarize hizi vitu zenye hizi zinafanana, ilienda wapi? Hello.
The previous comments to the
What was the comment about?
can't remember. Can verify for the new one, but
Juu naangalia kama unless kama comment ilikuwa tu something, but because me I feel whatever you are explaining hapa, whatever is Turing space for figure 7a represents alpha b parameter. I don't think this is relevant hata hapa sijui. That's you explain hapa. That table might help. So you see that maybe for example the Turing spaces for alpha b are also similar to the spaces for this. Turing spaces for beta rho are similar to spaces for this. Something kama hizo. But ukiandika kwamba Turing space for figure 7a represents alpha
ilikuwa
b
inachukua nani? It was actually taking more space, so that's why I reduced.
table.
Ilikuwa inachukua space kubwa in terms of
Kwani table inatoshanaje? Tiba hizi vitu inatoshanaje? But inafai kuwa two columns peke yake, ama inafai kuwaje kwani? 1 2 3 4 5 6, either 6 rows or 6 columns. Hiyo table itakuwa ndefu kweli kama unaandika tu 6 rows ya alpha b and then unapanga hizo parameters in one row. Hizi parameters hizi tosha kwa line moja. And then assuming you have a table inaanzia hapa mpaka hapa, and then iko na 6 rows of which itakuwa line moja, so unaweka hapa alpha b and then hizi zinakuwa kwa second column, then you put for example beta delta, then hizi zinakuwa kwa second column, hivyo zikienda hivyo. Kwani hiyo not figures, not table ya figures, table only with this special hiyo combinations are similar to these other combinations. Inakuwa tu columns mbili peke yake, no, columns mbili 6 rows. column ya kwanza ukiandika for example here alpha beta, then the second column inakuwa na hizi all these possible alpha betas, hii itakuwa kwa line moja, then the second row inachukua beta row, then second inachukua whatever is similar to beta row. And that's better than what itakuwa better than what you are explaining hapa. Juu whatever umeexplain hapa ni kama ume lose direction tena. Sasa kama for figure 7 the Turing space is represented the alpha beta parameter space with alpha b being another space with the similar configuration. In figure 7 the Turing space represents the alpha b two parameter space. Other spaces with the similar configuration consist of alpha this. So hata ungesema tu kwamba from figure 7a the Turing space for alpha beta combination or alpha beta or the alpha beta Turing space is similar to the Turing space generated by, and then you put these ones. Similarly, beta row Turing space is similar to the Turing space generated by hivyo tu, but ukianza katika hapa Turing space for figure 7a represents a Turing parameter two parameters. Now this confusing. Other parameters with similar configurations. Ona kama hii ndio nimeandika hapa, you sometimes kama hiyo table iko na hizo lines all six rows in fact hizi toka hapa mpaka hapa. Do is only just a single row, each row is a single line. So itapita hata hizi words ziko hapa ikienda hapa. In fact it will take maybe 6 lines peke yake kama something kama hapa. Hiyo table hizi shika kutoka hapa mpaka hapa chini. And it's better to explain that table than hizi words zenye whatever umeandika hapa in words. Alafu if possible so uko na hizi Turing condition hizo parameters zingine uko nazo mahali ulisave. Yeah, you can put them in the appendix. Hiyo weka huko, mtu akitaka atatoa baadaye, but for now you can put them in the appendix and then you refer to this. Somebody kitaka kuziona enda aone kwa appendix huko. Alafu hii disease yenye nataka nikwambie hii disease ya hour. To validate the Turing spaces in figure 7, we picked the fixed parameters in the black. I don't know now what is now. In fact, what you refer to the fixed parameters. You picked parameters in black region of figure 7a. To validate the Turing space in figure 7, we pick alpha and beta from black region of figure 7a with fixed parameters in figure, other fixed parameters in table 3, something kama hiyo. And ascertain that this parameter set of base stability conditions given in equation. Sometimes ukiandika hiyo kuandika kando kama equation kando. Wewe unaandika kwamba 23. Nimeona kuna press mbili imeandika hivyo. Maybe hata zingine pia, but nimeona mbili. And then says equal and it's better you break it. Kama ulikuwa umeandika kwamba the Turing space in figures, we pick parameters in black region of figure 7a, and this parameter produced as you see, you are having so many ands in this sentence ambayo ina confuse. So it's better una break, kama una break sasa hii sentence imeishia tu hapa hivyo, unaimalizia tu hapo. And then if you want to use this, unasema kwamba these parameters produce a sign matrix of the Jacobian that's consistent with the criterion for something kama hiyo. The steady, alafu ona kama umeandika the steady state for this parameter set was obtained as this using the root function in MATLAB. You see, hata yes. But nimejaribu kuchange, but nikacha kuandika tena. You make a comment. Now, nimeacha comment juu ilikuwa shida hii. Kuna mahali umesema these parameters. Mimi nimeweka tu capital T peke yake, but ulikuwa umeandika these parameters in small na and. Kwa hiyo nimeweka capital. These parameters, and then unakuja mahali ulikuwa unafanya singular. So kuna mahali ukuja tena ukaanza ukatumia, so nikashangaa ona the steady state for this, so nikakuwa confused again. What are you talking about? Is it oh, now it's confusing. Hapo unaongelea nini?
So we are discussing that set of parameters that is in
Which
singular
set of
form
parameter?
from the black region that produce the black region.
Now, where is that parameter?
A set of
Huh?
parameters. A set of parameters.
Ndio nasema,
C1
where is it?
from column 3.
Then mention kama ni set of parameter, then hapo ifai kuwa this. Kama unataka kurefer to a set, kama unataka ku parameters, then it is plural. So you have to be sure which one is you are using, and then you maintain you. Kama if you are referring to it as a set of parameter, make it singular and use singular everywhere. If you are mentioning them as parameters, then it's also plural, it's also valid, but then use plural everywhere. Kama utumia parameters. Juu mtakaza kusema hapa these parameters and then nakuja nasema this parameter, then another confuse. So if you want to use a set with this singular is okay. If you want to use this capital with the parameters, it's still okay. Just pick one, use that one ikiendelea. Hiyo una compute and then just refer to, instead of saying this, there's nobody who knows this you are referring to. Just no harm in repeating the number. So we select parameters from the black region of figure 7a, or to fix it, we select figure 7a, as shown in figure, or these parameters are in table 1, column 3. Full stop. Now, when you mention this parameter set, somebody knows, because this is like now pronoun not referring to what you refer to. But so kama these parameters hujamention kwenye umeshika, then unasema this, mtu anaweza kushangaa anatafuta hizi parameters this yake ziko wapi? In as much as mwenye amesoma somebody can quickly know maybe niyo mtu mwenye amefanya hii, but mtu mwenye hajasoma hata jua. So just no harm when you say you selected parameters from the dark region of figure. In fact, from this black region, the only parameters you can pick are alpha and beta. There's no other parameters hapa. So you have to make that clear. And since this table, ukiangalia table 1, iko na other parameters which might also be black region from different one. So exactly pick and write that parameter down, because sijui kama whatever umeandika hapa kama ya bit is changing 11.71 and this one alpha are for which region or for which Turing, because there are so many Turing spaces with the different dark region. So since those parameters you said kwamba ziko varying, zitoe huko juu, weke tu variable, weke tu varying, and then hapa now unaweza sema now you mention that you pick alpha and beta, or you pick alpha is equal to 1 and beta is equal to 10 from figure 7a, from black region of figure 7a. And other parameters fixed as shown in column 3 of table 1. Full stop. Whatever manika, then make a full stop. Then if you say now this parameter set produced or produces, just watch kuandika past tense, just andika your present tense, produces a sign matrix of the Jacobian that is consistent with the criterion given. How that one is, who cares? The steady state corresponding to this set. Yes, sasa leo naangalia tu some of this is because kama unaandika ukisoma kama statement umeandika hapa, the steady state for this parameter set was obtained as this. Using the root function in you see that statement, okay? No, what I'm writing is not optimal, but najaribu nasema tu kwamba try to make your statements to be concise to the point you want to pass iende. Si kwamba kijaribu kureplace ama kama maybe mine is good ama no, simaanishi hivyo, but is what I'm just trying to do is, from my understanding, is to try to just replace this with a precise statement yenye inatoana tu the message first and inaisha tu hivyo. Message ikiisha eka full stop, then enda kwa statement nyingine ongeza. Kama hapa, once the first message imeisha tu kwamba you pick the parameters to show that this parameter satisfies the stability condition, eka full stop. That statement imeishia hapo with the message iko clear. Then fully, now you want to justify. Why do you justify? Or how do you justify? Is that this parameter set produces a sign matrix of the Jacobian, whatever the Jacobian, that's consistent with what you know. You are now justifying the first statement as you wanted to verify. Now you are verified. And then you can now show the steady state now because you want to compute the steady state. Because when this parameter set is, then you have the steady state. Na hii inaisha tu statement, unafunga tu hapo, full stop inaishia hapo. And then next, you now evaluate the Jacobian matrix at this same steady state. Now the question is, between the trace and the Jacobian matrix, which one takes precedence? Which one comes from the other?
So you need trace and determinant from the Jacobian matrix.
Ndio nasema which one comes from the other one?
Trace determinant comes from the Jacobian matrix.
Then that tells you kwamba it's logical to start with the Jacobian. With this parameter set, you evaluate the Jacobian, the set of this Jacobian, the parameter set is given by, and then you give the Jacobian. The trace determinant and the eigenvalues of this Jacobian matrix are, and then you give them down. And then ona kama hii pia, you are now having an A and you are having a J. Ona sasa kama hizo mistake, because you are referring which A. Na hapo chini umetumia J. So I don't know why you put the A here because sijasema huko juu. So sijui kwa nini umeweka huko. But sasa ona ndio nilikuwa nimeanza kuandika part nikakuwa nikaachana nayo. Sasa nikashinda sasa sijui ndamalizia aje. And the same mistake. Sasa nikaacha kusoma tu hii pia. And then hizi what do you mean by the appropriate diffusion?
So there are two values. So you pick one that's more than one.
Yeah, sasa maybe. And then hizi vitu za substituting the values from Jacobian matrix into equation 37. Which values are who knows? And I don't know why maybe you can just refer to the number instead of saying our. Substituting values from the Jacobian, then you refer to that equation number, and then nasema and into this, and then unapata whatever unapata portion. So una substitute hapo. Greater than our then why did you have our here? Hapo mtaka kwanza unit ya Waluya yetu.
Luya unity.
Mbona but our imekuwa mingi and then kwenye ifit pia. Yes, it's good to show that this work was done by in fact, you are not alone. It's good that you're also not saying my computer, but instead of saying my computer, there's not hakuna haja kusema my computer because already you compute, just say whatever you computed the DC. And then sometimes use of this word finite parameters is also confusing now. I will try to avoid, kama ni mimi ningejaribu avoid it. Out here.
I delete kinetic. I delete the word kinetic.
Ngojea, linear stability greater than the gate control resistance. Linear stability one, implying that DC is bifurcation point. And a value of D greater than this computed DC Uh-huh. Hey. This application points and a value of D significantly greater than the computed DC with the value fixed parameters. Yeah, yeah. Hata unafaa tu yote. Asema tu kwamba with first of all one kuna shida, but asema tu kwamba if you pick D greater than DC, then you lose instability. You don't have to mention this with the fixed parameters. Whoever parameters, but once you pick values greater than DC with them in the Turing regions, you lose stability. So this is hiyo kitu kwamba with the fixed kinetic parameters, that one is hata isaidii chochote hapo, kitu ya kwanza. And then kitu ya pili, is it always the case that any D greater than this inatoa instability? Do you always get spatial patterns when this greater than this?
Mm.
No, hapana, hata si kufikiria juu uliifanya hapa, so you don't have to think. Uliona hapa mpaka you have to get the critical gamma, whichever for each D you are getting the critical gamma, and then you can only get patterns when you exceed that whatever that critical gamma. So if you have something that this ambayo for that it can, or maybe unasema it can if gamma exceeds the critical gamma for the patterns to form something kama hiyo. So you have to be careful kama hiyo, kama system kama hiyo. Na kama hii kitu hapa, I think there's something missing hapa. Provided that D is greater than this, then the range of ensemble wave numbers is obtained from the zeros K1, K2 of H1. Iko tu sahi statement kweli? First of all, did you have this HK squared somewhere?
Yes, when the conditions for Turing stability.
Refer to the equation number now. Eka K1 squared, and then unaandika mahali equation somewhere. I'm into bracket equation. So somebody can easily figure out. Mtu mwenye amesoma fika hapa, hata mimi atakuwa nakumbuka kwamba what is H squared. Then they may want to refer. So ukiandika hapa H squared, then eka tu hapo into bracket equation, then put equation reference up. We are obtaining this from the zeros of this, not zeros of from the zeros. Hii kitu hii ina confuse. You are obtaining this K1 and K2 are the zeros of H squared. That's correct. But so the message is, when mtu akisoma hapo the message ina mislead. Ama unaandika tu kwamba in simple to get the unstable wave numbers or the range of unstable wave numbers. We calculate or we find the zeros of the function hk squared. We did not, which we did not ask. K1 squared, and then something kama hiyo tu message. But unatafuta vile unaandika. But just jaribu kuandika tu kutumia tu simple statements, whatever they mean what you want. Just sometimes kama kuandika statement refu kama hii statement hapa, I think hii from nimeharibu hapa. The range of wave numbers are the zeros. Maybe ungeandika are the zeros K1, K2 of, because these are the zeros of this function. So you want K1, K2 are just the zeros of H squared, HK squared. Where HK, then hapo ndiko nakwambia kwamba refer to equation mbele. Plots of largest eigenvalue against n and H squared, because tunasema kwamba K squared is equal to n pi squared, against n are shown in figure 9. Each plot in figure 9 is called a dispersion relation. Within the unstable range, has a maximum for the wave number K obtained. Inamaanisha nini? Within the unstable range, real k squared has a maximum for the wave number k obtained from equation 31 with d less than greater than equation 31 iko wapi? What does it, kwanza hii statement inamaanisha nini kwanza? Hii statement inamaanisha nini? What is the message in that statement?
Mm.
Eh? Wewe vile umeisoma tu ukisoma inamaanisha nini? Ama wewe vile uliandika? Eh?
Mm.
Unaona sasa kitu mimi nilikuwa nasema juu kama sasa if you are struggling to understand na wewe wewe ndio uliandika then what will happen to somebody who was not even written this? Juu sasa sielewi message gani ulikuwa unataka kupitisha hapa. So unaona? So na mtu akiwrite kitu it's tricky for somebody to write even this statement juu aelewi inamaanisha nini. Ndio mtu anaitabisha kwamba ajaribu kusoma aelewe what you meant ndio ajue maybe anaandikaje. Jote nikisoma kama statement P from question 37 31 we note that hk squared is a quadratic expression. Hata maybe hiyo pia sijui kama inatoka. H squared is a quadratic expression in k squared with the coefficients that solely depend on the system's parameters. D, the diffusion coefficient and the parameters. The minimum value H mean occurring at k is equal to k minimum corresponds to the associated with maximum real and consequently the mode. Hey, hata them the minimum value H mean that occurs at k is equal to k corresponds to lambda k squared associated with the maximum real lambda k squared. Fully stop. Consequently, the mode with the highest growth factor is expressed as exponential this. The value H mean. So you see, sasa, why do you need this? And then you are having this. Hapa. Why don't you just write here the minimum value H mean into bracket equation 34 occurs at K is equal to Km. It or it corresponds to lambda K squared associated with the maximum real K squared. Consequently, the mode with the highest growth factor is expressed as it's just I don't know why this consequently. As because it occurs with the bifurcation point distinguishing between spatially stable and unstable modes occurs when H is equal to. Through the variation of gamma, we can selectively excite specific modes and a process referred to as mode isolation, keeping all systems parameters constant as given in column 3, table 1. Each pair of parameters dy defines a distinct parabolic curve given in that hizi equation number ukaandika hizi thereby specifying a set of unstable modes. Consequently, you are having these consequences, so many of them. Why does this become consequently here? Because consequently, if it's something happening as a consequence of what you wrote before, what you did before. Consequently, the dy plane can be divided into regions where certain modes or groups of modes exhibit diffusive instabilities. A plot of dy gamma is given in figure 8. Hey. Ah. When you read these papers of people who do, what do they write in these kind of statements? Wanaandikanga nini? Ona kama umeandika hivi. Excited wave numbers in dy gamma space correspond to systems 9, while other parameters are fixed constant away. Maybe. You just which ones are fixed. That's what kusema while. Sasa excited wave numbers in dy gamma parameters correspond to system 9 with parameter computed with the parameter values in column 3 of table 1. Please stop. The color code represents that one is representation. In this diagram, the colors represent the wave modes that can be generated when values of gamma and the diffusion coefficient are varied. Within the spaces, we characterize the nature of the modes that can be specified by the border lines that demarcate the spaces and are labeled NIs. Hey, where NIs represent the starting mode type. For example, the red color shows 3 modes, and the nature of these modes depend. So you use modes and depends on the locations of specified by NI. That is, the region NY red has modes of type K1. Region N2 has modes of type K2. Hii figure usipoiklimi mtu ataona kwamba atakwambia kwamba hii figure itakana hapa juu. Siona kama umeexplain hapa. So we plot the gamma space which isolate different modes which are excited when they are changing at different values of the gamma space. And so we color code, and then you with this starting by explaining what is this NI represent and what is the different regions represent, this color coding. So each color code refers to the number of modes which are excited, and NI refers to the starting. But that one, but sasa kitu kama sasa soma and then uone kwamba is there a way you can write this better, somebody can understand better? If you still understand it the same way, then keep it. If not, then change it. Why do you have a version of 5 modes? Upon examination of figure 8, we can observe that the flexibility available if 5 mode patterns is required in the development sequence. Although the parameter sets may not differ significantly in the qualitative aspects across various actual diffusion systems, what does differ is the size and shape of the Turing space. This variation provides another valuable criterion for comparing relevant robustness of hiyo sielewi. Wewe unajua kitu tufanya sasa, mimi sasa ujue mimi sasa hiyo nini kusoma hata sielewi. I understand this figure at least because ulikuwa hapa and then I saw it. I've seen it several times, so at least I have some ideas. But when I read the statements, then still it's tricky to connect the statement na the figure. So that's the point. Or just quickly mention somewhere this table 2. You maybe then you can refer to figure and then figure table 2 at once. Why do you say get it using MATLAB? Figure 9, what is figure 9E? 9 and 9E. But why do you say figure 9A to 9E and just one figure and all of them is going to the same nature? Why do you say just figure figure 9 shows the dispersion relations. Sijui kama dispersion, are they dispersion relations? Nasema kwamba figure 9 refers to the dispersion relations for choosing, and then you explain what it means. Because it's saying 9, 8, 9 in, then they are figures of the same type. Isaidi chochote. I still, in this subsection, we have isolated, we have showed different modes are exerted with different parameter combinations or D gamma combinations. To validate these findings, the next step is in the subsequent subsection involves performing numerical simulations of the homogeneous system. Hi. We have demonstrated the mode isolation for different parameter combinations of delta gamma. Next, we validate these findings by numerical solutions. I'm presenting us. Sijui utawekaje. Validate these findings, we numerically solve system or in homogeneous system figure in MATLAB on what might be in 1D and 2D with these parameter sets. These simulations will be conducted in both 1D and to validate these findings, we present numerical simulation results corresponding to system 8 with the parameter values fixed in this. If you fix some, you picked from these different regions. It's because sasa tutawekaje. And what do you do when you do these parameter sets? We make sure that you are keeping the parameters in the table fixed and you are only changing gamma and beta, and then explain why you are changing gamma and beta if you are changing or if you are fixing, which one you are changing. And then you present two sets of numerical simulations. One, the first set, you are computing this in MATLAB PDE function in 1D. And in 2D, you compute something similar, the same thing, using finite difference method. Yes, then umeshasema linking and umeshasema huko juu validate, so I don't think iko relevant hapa. But when you write utaona kwamba hii itapotea tu, but I don't think iko relevant. Hii kitu hapa, hii ilikuwa describe tu vizuri hapa. I think the description iko vizuri hapa. What I'm just wondering is This again seems like a repetition. I don't know, but if you check, I don't know if it's a repetition. Juu kuna mara think umemention kwamba point to reverse traces of parameter values from the appropriate parameter regions. Umeandika something hapa. And then I think you are now repeating similar statement hapa chini. At least the description hapa, it can be followed. But sasa hii kama hii kurudia kama hii statement hapa naona kama imerudiwa. We begin by conducting one simulations using PD. Hii hujamention hapa. Ona kama hii pia. And then you are repeating the same statement hapa chini. These simulations demonstrate that when at least one of the Turing conditions are, yeah, way. Kwani it started very well. Tena inaanza kuisha hadi tena. Ona kama sasa hii. Baada pia umeona tu. In fact, hii kwani ama ulikuwa unafanya reflection?
Mhm.
Eh? Juu hata hakuna haja kuhighlight juu umeona tu wewe mwenyewe umeona tu kwamba from here until here is repetition of the first paragraph, sio? Juu ile pia umeenda mpaka ukafika tu hapa kwa Z full stop. Then is the same thing umekuja ukafanya tu hapa chini kwa Z. The only difference kwamba hapo equation uliandika kama hiyo displayed hapo uliandika within the sentence. But wewe mwenyewe soma hiyo uone kama is the same statement ni umereflect hapa chini. No, this explanation hapa is idea hapa. Hii hapa naye singeweka hii. But you selected just cosine functions because they are just the modes you selected, not because they provide a clear way. No, I don't think this one does not make that harder to. What you are just trying to pick, you want to show the correspondence between the predicted linear solution and the nonlinear solution, and that's why you pick these modes. When you pick linear solutions as these modes, then you are getting the corresponding nonlinear solution, not because the random ones zitakuwa harder to interpret. If you are having patterns, then you pick random perturbations, you'll still get spatial patterns. What you don't know is which where will it go to which, because kama uko na so many modes which are excited, then it will go to one of these. Then you are not sure kwamba which one will be itakuwa attracted, itakuwa gonna pick random perturbations. And then with random perturbations, when you make the next round of simulation, you are not using this, you are using a different initial condition. So somebody may not replicate. If you used one and then generated this mode, somebody may not reproduce your results because the next time at run, produce another random perturbation and then it will produce another initial condition which might go to a different mode. But in the long run, see, itakuwa harder to explain. You just wanted to do this so that you can provide a correspondence between the linear solution and linear solution. Hata mwenyewe uliona kwamba the modes are of this nature, cosine n pi x.
Mm.
Yeah, so this is what you saw. Those are the modes. And the good thing is hivi ndio nafanya ndio nafunza hapa ma second years. But sasa for only one equation. Hizi mambo za eigenvalue, eigenfunction, eigenvalue, eigenfunction. No, eigenfunctions of this solving the, for example, the heat equation in 1D and then extracting this eigenvalue, eigenfunction, solving the wave equation also by separation of variables. And then it connects very well to this Fourier series. Hizi ninafunza hapa, hiyo ninafunza third year, sasa hiyo third year. But so the point sasa hiyo kitu ambayo unafanya paso si ati ni harder. For clarity, we will mostly present the solution for you and the configuration for V. Figure illustrates the case where parameter values are Figures 10 shows numerical simulation results corresponding to system 9. I don't know if it's 9 or 10 or 11, corresponding to system that number with alpha and beta is equal to 30 and other parameters fixed as in, and then you mention those fixed parameters. And that statement inafungua tu hivyo. So here we selected alpha and beta outside the Turing space region to illustrate that we cannot get spatial patterns. And then you explain, indeed, it can be observed from figure 10 that, or you can see from figure 10 that the solution goes to a homogeneous steady state. And then you can pick this value, which is exactly the steady state we computed. You relate this. That's the message of this. And you see, and just mention some of this. Figure 10 shows numerical simulation results corresponding to system 11 or system 9 with alpha and chosen this. Or figure 10 shows 1D numerical simulation, because now we are having 1 and 2D. So you may want to put this corresponding to this with, always you have to tell people where those other parameters are. Kama ziko fixed mahali, what you change, what you mention, you change, what you change and then you mention. No, just don't put this with respect. Just mention, just say come with other parameters. We are picking this outside the Turing regions. PDB numerical summation of model system 9 with alpha and beta, D and these are not the homogeneous solution because inaanzia hapa chini, so it is so no homogeneous ikifika huko mwisho jikishia converge, but huko chini sio homogeneous. Just shows, andika tu maybe A and B shows contour plots of this U and V in time, and then this one shows C, the discrete L2 norm of the time derivatives. It can be observed that the evolved profile of concentration U and V uniformly converges to the steady state values, forming neither spatial nor temporal patterns. As anticipated, theoretically, selecting parameters outside the Turing space does not lead to pattern formation. Consequently, any parameters choice outside the Turing will be consequently. Just don't say consequently, just mention kwamba I'll try to avoid this, because you may pick a parameter outside the Turing space, and that parameter happens to be in the bistable region. And so you may not get, maybe you'll get a homogeneous, but I don't know. Or maybe you may pick a parameter outside the Turing region, and that parameter happens to be in the oscillatory regime. Because ukisema tu kwamba it's outside Turing, you don't mean it's always stable. You may have also parameters which are unstable, also belong to that space. And so when you pick parameters, it may go to the oscillatory dynamics. So kama unaona kama ina confuse, leave it and then explain only what the information you know. Hapa sasa umeanza kudanganya. Hii statement inadanganya, expression growth due to, hapa hiyo unadanganya bwana. Why am I saying? Umeona anywhere hapa ukiwa na exponential growth? Ha? Hakuna. That's one. And two, nimeruhusu nadanganya kwa nini? Because that statement is valid when you have spatial patterns. Because in the spatial patterns, you start by decaying And then you have this exponential growth. And then linear terms force this thing to come down and stabilize. So if it were a linear solution, because of the exponential t, it will grow. It will grow above. But now it's forced down by the linear term. So this statement is valid when you have the Turing patterns. Kwa sababu nimesema kama unadanganya juu iko valid huko, si huko kwingine kwenye iko stable. Na hata tu ukiangalia hapa stable, there's nowhere exponential growth. If you don't know what's happening, it's better explain visually what is shown on the figure. Nobody will tell you that you are wrong if you explain what is in the figure. Juu hakuna hapa exponential growth hapo. Similar results are obtained when all parameters are chosen within the Turing space. Yeah. Hey, hey. Similar results are obtained when all parameters are chosen within the Turing space. For example, by taking the black region of this as our reference, but with the value of division coefficient less than the computed critical DC. The same results were obtained using the finite difference method in 1D by taking time steps. No, wachana hii kando, wachana hii. But niko tu hapa, shida yangu iko tu hapa. Similar, what do you mean similar? So unasema tu kwamba just and nilikwambia kama something iko tu different message, give it another paragraph. Similarly, one can show that picking parameters from the Turing region, but with or selecting the D value less than the D critical, there is no, or the steady state is not destabilized, or diffusion does not induce the stability. And so this gives similar results to what's observed in figure 10. You see, so a message of that one, nikwambia ukiandika one paragraph, people connect those messages as one. And so akianza kama message imefika hapa, then anaweza kama similarly when all parameters are chosen from the Turing spaces, for example, then anaweza kushangaa juu pia mimi nilikuwa nafikiri kama umeshasema mambo ya Turing tena. So I now get your point. You want to show that if you pick parameters within the Turing, but fail to satisfy this critical D, you cannot get spatial patterns. That's true. And so just make this up another point and write it well. Similarly, one can show that if parameters are picked from the Turing region or the Turing spaces, and you can refer to just for now refer to the figure 7, two spaces generated in figure 7. But if the critical D is not, or if D is less than the critical D, there is no destabilization of the uniform steady state. Najua nimesema ya pili niko tofauti na ya kwanza, but so the message I'm trying to bring is what? Just make another statement, write it, and make reference. What's the message? The message is when you pick parameters of the Turing region and fail this D, then you cannot have spatial patterns. Just have it a different message of its own. Having seen or having shown that when Turing conditions are not met, the uniform steady state is not destabilized, fully stop. Or you have seen that if Turing conditions are not met, the uniform steady state is not destabilized, fully stop. Next, we compute or we simulate system 10, whatever come at 10 or 11, with parameter values selected in the within the Turing space or Turing regions, and observe or investigate the effect of varying gamma on the same parameter set or the fixed parameter set. And then you can now just briefly explain Here we pick gamma values as gamma 1, gamma 2, gamma 3, something. And then you mention those gammas. And then nasema kwamba now, ukisha explain what this message is all about, umesha summarize what you do this in one day. Then now just mention figure 11 shows numerical simulation results corresponding to system 11 with D is equal to 10 and gamma is equal to 10 to 20. And other parameter values fixed as in column 3 of table 1. Fully stop. And then you can explain this figure. And then once you get, I think kuna siku nilikuwa nimekuambia kwamba just focus on one figure only. Make sure that you bring that message of one figure. Once the message of this one figure is clear, like this partial pattern, then you are having a similar message for these other figures, all of them. So once this message, just only this one is clear, then you have a similar message for these other figures. And then just do this, and then you repeat. And then once you finish, now go to the next part, and then you are having the same message repeated, but validating. So next, in the previous section, we observed the numerical simulation of system in 1D using the PDPE. We are going to repeat or similar solutions or solve this model, in this case now, in 2D on a square domain, 01 to 01, using finite difference. And then you now explain. And the figures will follow the same thing. Wacha niende nilale, kesho nitaamka 5. Niko na hope.
Thanks.
Yeah. So ukisoma hizi vitu vile nilikwambia tu, najua ulikataa kusoma hizi vitu. Sit down, some of these statements, read it again. Try to pick out some of these mistakes like this kama niko tu, at least some of the words maybe see kama maybe you'll have to pick exactly maybe words vile mtu unexpect, no. But some of these things like zenye ziko tu repeated up exactly tu kama hizi, then you have to pick out some of these things. Hizo, so sit down, dedicate your time, at least hii ndio watu wako kwa strike. Dedicate time and don't rush to finish so that you submit. Say that I am going to work on this so that I complete it. By completing, it means that whatever you have done, you are satisfied. You know, there is something unaweza tumia mtu akasema kama huyu naye sasa nimtumia sasa atasema nini? You are worried. But there is this case where you can send somebody to something, you are confident that yes, I know mistakes will happen, but I'm sure that what I did it to my best, and that can only happen when you read it slowly. Then you are satisfied that on my part, I think what I've done, and maybe to my level, is okay, is sufficient. But najua usiposoma kama usipopitia hii kwamba maybe let me just only pick out where kuna mistake halafu ni correct reason, then you send this thing, but again you are just masikio imesimama tu. Sasa atatuma correction, sasa atasema nini? So that means you have done something and you are not confident yourself that what you did is good thing. So isome mwenye, hata ukitumia mtu, hata kama atatoa mistake, but utakuwa sure kama no, I know kwamba what I did to my level, that's the best I could have done it to my level, and then I learn more vile zinakuja. But usiache kusema kwamba sasa hii next maybe atatoa mistake zingine tena ama atafanya nini. So still the ball is in your court. Wewe mwenyewe kuikalia tu, uyaangalie. If you will correct something, then nikiamuka not asubuhi akiwezi sitaangalia. Kitu saa 5 saa 6 hapo after classes na office hours, then I look at it. At least umerecord sasa hiyo, so unaangalia. So I'm gone.
Thank you.
Yeah.